Hello and welcome to the Algebra 2 series again. Today we're going to be working through completing the square to graph a parabola by transformation method. And here's our parabola. We're going to write it over here, f of x equals, and right away I'm going to factor out that 3 that's in the front of the x squared in order to complete the square. So we've done one of these in class and we're going to do another one here. This time we've got an x squared minus x as we factor out the 3, and we leave a space for our third term, bring the 2 to the other side here, and then leave an additional space. This is the most critical step in order to solve this out. And so in doing so, we go to the next step. We like to put the next part in, and we use our technique for completing the square, which is to take half of that first term here, which is -1. So half of that would be -1/2. Keep in mind this is going to be squared here. When we take 1/2 and square it, we end up with +1/4. That goes back up in here. Now we're working on the same side of the equal sign here in the function, but keep in mind it's not just 1/4. We have to multiply it by that 3 right over there. So in doing so, we're going to subtract 3/4. Now it's always a tricky step there, but once again, recall that since this is an addition over here, we are adding 1/4. We multiply that by the 3 to subtract off what we added. So that's what we do in this last step. Finally, taking 2 minus 3/4 is going to be plus 5/4. Now that one step gives us our transformational parabola, and at this point we still need to graph it out. So we'll start writing some of those things out, starting with the original root graph x squared, and I put an arrow in here just to indicate that this is our root graph. A little happy face there. The first step, or the first transformation, is to apply the half, and this half applies to the horizontal because it's stuck in there with x, so we would call that a right shift by 1/2, or just r 1/2. The second one is the 3 that is out front. Of course, this is not pertaining to x, this is pertaining to y, because it's not part of the quantity. So this one is called a MOX, M-O-X-3. We've done this before also at the beginning of algebra here. And then our last one is the plus 5/4, which is x minus 1/2 squared, and then plus 5/4. Again, the 5/4 is with the y, not with the x, and therefore it's a vertical translation up 5/4 of a unit. We have these 3 transformations, and they are the 3 that we're going to apply to our graph. So I'm going to just move this guy up a bit here, bring it into play. We'll start with the root graph, and we'll put that in dotted here. It's our parabola. Keep in mind we have 3 points that we want to transform: 1, 1, 0, 0, and -1, 1. Let's begin with 0, 0. The 0, 0 is always the easiest one to transform. So starting with the right 1/2, we'll move the point right 1/2. That's where it goes. And then MOX 3, it's on the x-axis, so it does not get affected by that, but it does get affected by the 5/4. So it is at the final resting point is going to be right here. I'll just put a little arrow to that. That is going to be 1/2 5/4, and that's going to be our vertex. Second point, which is 1, 1. If I move that to the right 1/2, that's 1.5 comma 1, or 3/2 comma 1. MOX 3 is going to bring it up as a multiplier, so instead of 1 unit up, it's going to be multiplied and be 3 units up. So I'll be at 3 here. So that would be 3/2, 3, and then finally up 5/4. So this is a very tricky point. It comes up about here somewhere, and it is going to be at 3/2, and then 4 and 1/4. So that would be 3/2, and then 4 and 1/4, which is 17/4. That's a very tricky point right there. The nice part about this is that the other point will have some symmetry here. So using -1, 1, move it 1 half to the right is going to be negative 1 half, comma 1. Mach 3 is negative 1 half, comma 3, and then up 5/4 is here. And so all we really need to know is the negative 1 half part, because it's going to be horizontal with the other 17/4. We'll put it in right there. So that was a very tricky couple of points to transform. Not so much the origin point, which turns out to be at 1 half 5/4. That's going to be our vertex point. But the other 2 points, the ones that transform from 1, 1 and negative 1, 1, are very difficult. And finally, let me summarize this and finish it out by writing the domain and range. The domain for the final function here is going to be all reals. So x is a member of the reals. And then the range is going to be y such that, and notice the y values begin at 5/4, which is our vertex value right here. So we would write y is, let me erase that, y is greater than or equal to 5/4. I'm not certain if that's going to be requested, but when it is, you can put that in there. And there you have it.